my favorite teenagers. It's been a while. And today I just heard on the news that they're going to keep school closed for the rest of the year. So I miss you. I'm really bummed I won't get to see you again this year, but oh well. I know you're probably bored too, but we're going to do this and it's going to cure your boredom and you're going to be like, Mrs. Oldham, thank you so much for this wonderful gift of math. All right, so chapter 7, sequences and series. Stop groaning, okay? A lot of this is stuff that you guys have already had. And a lot of it is just formulas and putting things into formulas and crunching numbers. So you got this. This is exciting. We love it. And so what we're going to cover is 7.1 through 7.5. However, 7.1, surprisingly enough, is one of the harder sections in this chapter. So I'm going to kind of sort of skip it. I'm going to take pieces from it as I go. And then, so it'll kind of get mushed in with the rest of these. So today we're actually going to do 7.2. All right, so 7.2 is analyzing arithmetic sequences and series. And yes, it's pronounced arithmetic. If you're speaking about it as if it's a noun, it's arithmetic. If you're using it as an adjective, it's arithmetic. Okay, I don't know if you've ever played the game Sequence before. We have it. I've never played it. But that's what I thought of. All right, so just a few quick vocabulary words. This is definitely going down memory lane. I know this because I just taught this to freshmen, so I know you've had it. All right, so it's up to you whether or not you want to write these things down. Some of these I think you just know. A sequence is an ordered list of numbers, all right? So you've got your group of numbers, but they are ordered. You have your first one, your second one, your third one, your fourth one, and on and on. Okay, the values in the range are called the terms of the sequence. And these are, I'm gonna grab my notes here real fast. Okay, so that's the range. The domain is the place that the terms are in. So first place, second place, third place. That's your domain, 1, 2, 3, 4, etc. All right. A finite sequence, well, what does infinite mean? Infinite means going on forever, right? So finite means it ends. You have a finite amount of things. So a finite sequence is a function that has a limited number of terms and whose domain is finite. So I have 20 items, it's 1 through 20. Okay, an infinite sequence is a function that continues without stopping and whose domain is the set of positive integers. Okay, the domain, I'll say that again, the domain is the set of positive integers. So basically we're counting 1, 2, 3, 4, 5 forever. Okay. So if we look at this kind of more as a picture, I guess, okay, your domain, start at 1, because that's your first term, your second term, your third term, and it goes on forever for an infinite sequence. And a sub 1 is the number that's here. Okay, so for example, a finite sequence could be 2, 4, 6, 8. Infinite sequence, 2, 4, 6, 8, 10, 12, on and on and on, dot, dot, dot. Okay, so a sequence can be specified by an equation or a rule, so the rule of this sequence. For example, both sequences above, so these right here, can be described by the rule a sub n equals 2n, right? If a is 1, 2 times 1 is 2. If a is 2, 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8, etc. And it can also be written in function notation. So this is sequence, this is written as a sequence, this is written as a function. Okay, so an arithmetic sequence, because we've got geometric and arithmetic and probably some others, I don't know what they are, but there's probably more out there. In an arithmetic sequence, the difference of consecutive terms is constant. This constant difference is called the common difference and is noted by D. You know, because D stands for difference. So basically, all you're doing is looking at your numbers. What are they being added by each time? That's all. Or subtracted. And that would be being added by a negative. But what is it that is changing by each time? Okay, so example 1, identifying arithmetic sequences. So all we want to know is whether or not these are arithmetic, that's all. So let's look at this first group. Okay, what is the difference between -9 and -2? Well, if I add 7 to -9, I get -2. Well, -2 to 5 is also 7. 5 to 12 is 7. 12 to 19 is 7. So this is arithmetic because it is increasing by 7 each term. If I come over here, 23 to 15 is 8. -8. 15 to 9 is -6. We could just stop there because we know right away that it's not arithmetic. Okay, there is a pattern. But it has to be a constant number, or a constant. Okay. All right. So, a rule for, this is important, you're going to want to write this down. Okay, the rule for an arithmetic sequence. This is an equation that you've seen before. I know you've seen it before. And it's what we use to write the rules for arithmetic sequences. Okay? And it's right here. So if you need to pause it and write this down, then go ahead and do that. But this is the rule, and what we're trying to find, we need to find a sub 1 and D. So n just stays n in the equation because that's what changes, a sub 1, a sub 2, a sub 3. So we keep it at a sub n. All right, so writing a rule, let's look at this one. And let me look at my time. Okay, we'll do this in the next part.